In this video, we will have a closer look at length-oriented objects. One example of a length-oriented object is the conveyor, which is used to transport parts. As you can see, we have already built a finished model, which we will now rebuild. To do so, we will insert 3 stations and conveyors in between them. So, let's start. First, place 3 stations and leave space between them. In this space, we will insert the conveyors and connect the stations. To do so, we create a conveyor and click on the first station. In this way, Plant Simulation will know that the conveyor should start at the first station. Now we have to select a destination. To do so, we click on the second station. Plant Simulation will now recognize that this is the destination and place the conveyor exactly between them. We do the same for the space between the second and third station. If we now start the simulation and let it run in real time, you will see how the conveyor conveys parts between the stations. Since the destination and the starting point are not necessarily on the same level, we have to use curved conveyors to connect them. So let's create an example for that case. We insert a source and 2 stations again, but this time not on the same level. Now we click again on the conveyor icon in the Material Flow toolbox and place it on the first station. If we now click and hold the Control key and move our mouse upwards or downwards, you can see that a curve is created accordingly. To insert a curved segment, we click on the left mouse button. The first segment will be inserted in this way. We then insert a straight and afterwards the second curved segment. Then we insert a straight segment. The dialog that is in the left corner, while inserting conveyors, provides the functionality to delete the last anchor if you misclick with the mouse as shown. As you can see, we are not on the same level as the second station. We can now make use of manipulators. Manipulators are used to change the graphic or the dimension of an object. First, we need to make the manipulators visible. There are 2 ways to do this. The first one is by right-clicking on the conveyor and clicking on Show Manipulators, or by simply selecting the conveyor and pressing the M key as shown in the context menu. After making the manipulators visible, you will see the anchor points. We can now click on the last anchor point and drag it on the position of the station. By doing this, we stretch the straight elements of the conveyor. As you can see, the angle of the curved elements are by default 90 degrees. However, Plant Simulation provides the possibility to make more precise adjustments. To showcase this, we will insert a curved segment again. After inserting the curve, you can see the same dialog in the upper left corner of our window as before. As you can see, here are several parameters we can adjust. For now, we will not go in further detail, but feel free to try different adjustments. We will now move the second station and the drain away. Now we have again a gap between the last anchor point of the conveyor and the station. Instead of using the manipulators to stretch the conveyor, we can also append a segment to the conveyor. Therefore, we right-click again on the conveyor and click on Segments. Now we click on Append and are able to append a new segment. It is also possible to delete the last segment of the conveyor. To do so, we first make the manipulators visible and can right-click on the last anchor point and click on Delete. We can deeper analyze the segments by opening the Segments table. This is possible by right-clicking the conveyor, then clicking on Segments and then selecting Edit. You could also use the shortcut F7 as shown. Now a table will open, where each row represents a segment of the conveyor. Here we can adjust several parameters of each segment. We could change the length of the segments or adjust the radius of the curved segments. We could, for instance, change the curve angle to 80 degrees. In addition, the manipulators show us the conveying direction. At the anchors, we can see at which direction the parts are conveyed. We can also split up the conveyor by right-clicking the conveyor, clicking on segments, and then on split up. Now we dive deeper into the conveyor itself. By double-clicking on it, we can open the dialog of the conveyor. Here we can adjust several parameters. One of them is the speed, which determines how fast parts are conveyed. Another parameter is the gap type. We can choose from 4 different types. The first one is the default one. This determines the gap between the rear of the preceding part and the front of the succeeding part. Then we can choose pitch. This determines the gap between the front of the preceding part and the front of the succeeding part. MU distance, we can enter the intended distance between the parts. The default value is -1. At this value, the gap type is not considered. We will now enter 0.5 as MU distance of the conveyor we split up before. Then we bring together the conveyors, the station and the source. Now we start the simulation. As you can see, the gap type is now applied to the conveyor we split up before. Now we look again on the remaining gap types. Minimum gap determines the minimum distance between the rear of the preceding part and the front of the succeeding part. It also prevents the conveyor from stopping and from waiting for new parts, and allows it to run dry. Minimum pitch does the same for the pitch gap type. As you can see, there is also a checkbox to enforce the MU distance. If we check this box, the conveyor will enforce the parts to keep the gap type, even if they accumulate on the conveyor. As always, you can get help on gap types by clicking on the question mark and clicking on the box. The same applies for the Enforce MU Distance checkbox. Now we want to show how to use different height levels with the conveyor. Therefore, we create a new model frame. Here we insert a source, a conveyor and a drain. Then we insert another conveyor, which will cross the first conveyor. Naturally, in a production line, we want that the second conveyor should go over the first one. We can achieve this in plant simulation by making use of the manipulators. First, we make them visible again by using the shortcut M. Then we click on the second anchor. Now we have 2 options to edit the height. We can hold Shift and Control and use the up key. In this way, we will move the anchor by 1 meter steps. If you just hold the Control key, the anchor will move by 10 centimeters. If you have exact coordinates, you can also double-click the anchor point. In this way, the Edit 3D Properties window will open. Here we can enter exact coordinates. As you see, the second conveyor is more like a ramp rather than a bridge, and it also does not provide an incline. This is because we just used 2 anchor points. We can do better by using more anchor points. So let's delete the second conveyor. We now insert a conveyor with 6 anchor points. The first part of the conveyor will be straight. The second one will be the incline. The third part is the bridge over the first conveyor. The fourth part will be the decline, and the last one will be straight again. To get a bridge, we select the third and fourth anchor point. Then we move them up by holding the Ctrl and Shift key. If we select more than one anchor point, we can't use the Edit 3D Properties dialog, so we have to edit the height by using the shortcut. We start the simulation again. As you can see, we have now a perfect second conveyor. This concludes our video on conveyors.